Hey guys! Okay, today I'm going to teach you the chapter 2 units of derivative, unit 2, the limit of a function. So before we do some example, I want to review some concept with you guys. So the vertical line x equals a called the vertical asymptote of a curve y equals fx if at least one of the following statement is true. So what this definition basically say is, as the limit of a approach from the left and right sides, they have the same value, then the value of fx when x approach to a equals the value they have, the same one, as you can see here. So let's actually do some example. So example on page 92, number 9. For the functions f whose graph is shown, state the following. And here is the graph of the function. Actually, I copied down the question and I already did them. So I just explained how we can do this. Okay, so here's the graph. And for question number A, find the value of fx when x approach to -7. As we know from the definition, if the limits approach from left and right sides of -7 the same, then the equal, like for example the equals L, then the limit of x to the -7 fx equals the L. So let's find the limit of from the left sides approach to -7. And as we can see from the left sides of at -7, the value go down to -infinity. So we got the value limit f sx goes to negative 7, the fx equals -infinity. And the same one with the limit sx goes to -7 from the right sides, fx equals negative. So we can tell that the limit sx goes to -7, fx equals -infinity. Okay, for question B, you're asking us to find the limit as x approach to -3 in the graph. As x approach -3, if we want to find the value the same with the previous question, we need to find the value of limit as the limit goes to -3 from the left side and right side. So we can say the limit as x goes to -3 from the left side, fx value equals infinity. And as it from the right side, the value still goes to infinity. So they have the same value, infinity. So we can tell the limit of x goes to -3, the value of fx equals infinity. Okay, for number 3, we need to find the values of fx when x approach to 0. And cutting here, it's the same with previous two questions. We need to find the limit, find the value of fx as the limits approach to 0 from the left and right sides. As the limit approach from the right side, we can tell the value of 0 goes to infinity. And from left side, it goes to infinity too. That's what I write here. So we can tell the value of fx as x approach to 0 equals infinity. Okay, do you have a couple more? We need to find the value of fx as the limit x goes to 6 from the left side. Okay, here, according to the graph, this is 6 from the left side. The value of fx goes to -infinity. So can you write it? Because it's a bit confused. Okay, it's negative. And for the last one, we need to find the limit as x goes to 6 from the right side, the value of fx equals. So according to the graph, you can see from the right side, the value of fx goes to infinity. So the value of fx equals infinity. So I have one more extra question. Is the value of fx when x approach to 6 exist? Well, so we know if the one have the same value, then this number, when x approaches this number, have the actual value. As we can see here, when the limit approach to x equals 6 from the left side, the value is negative infinity, and from the right side, the value is positive infinity. They are not the same. So we can tell the limit as x equals 6, the value of fx do not exist. Cool.